Hey guys, what's up everyone? Welcome or welcome back again to another video tutorial lesson from the AP3X Institute of Mathematics Education. My name is Akeen, your math instructor, and in today's video we're going to be completing part 3 of a three-part series covering the concept of coordinate geometry. Of course, if it is that you have not watched the two previous tutorials, be sure to check the description box below. You're going to be finding links that will bring you directly to those videos, as well as checking my playlist. You'll find other videos related to other aspect or other topics related to the Csec, CCSLC, SEA, and other related math courses. Of course, we're looking at the concept of coordinate geometry. In our last video, we had looked at finding the gradient. We had looked at finding the length of a line, midpoint of a line, and of course finding the equation of a line. Added to that, we also looked at some structured examples and some questions that had a little bit of twist in them. So you definitely want to check that out before you actually log into this particular video. Now, if this is the first time here on the channel, then be sure to smash that subscribe button to be notified on a weekly basis. Don't forget to turn on the notification bell. So on a weekly basis, you'll know whenever I post contents related to the CSEC syllabus. Of course, lots of past paper videos are coming, past paper questions from previous years, and of course recent years. So be sure to have that subscription button turned on. Of course, if you're getting any sort of value from previous or current tutorial videos, be sure to leave me a like. The comment section is open for you guys to leave your comments, video requests and suggestions, concerns, and of course leave your compliments down below. And of course, check in the description box below. You'll find not only links to other useful videos, but you'll find a link that will get you directly in contact with me if it is that you're seeking tutorial sessions, private sessions of any sort. All right, now be sure to share this out to your math group, friends, family. Each one help us to grow so we can master this and many other topics under the CSEC syllabus. Let's jump right into the video and discuss what was talked about in our last video. Now, in our last video, as you can see here on screen, we had went through a few examples. Using the method of y equal mx plus c. Looked at various examples here on screen. Be sure to check that video out. A link is in the description. Now, in today's video, we are actually going to be introducing to you here an alternative method here of finding the equation of the line. Now, I really like this method because what this does for me, or what this does for why you find a lot of advanced students using this method, is that we are able to calculate two things automatically. We are able to calculate the equation of the line automatically, and we're also able to calculate the y-intercept automatically. Now, as you can see here on previous screen, we had to calculate m, we had to interject m into the formula. Then, as you can see here, we calculated c, and then we had to draw a conclusion. So I kind of feel like that's a lot of work to do when we have this method here that can kill two birds with one stone. So that's what we're going to be looking at. And so this new formula here is going to be a formula that says here that's y minus y1 equal m times x minus x1. We're going to be looking at that. So when we look at this formula here, I had to insert a little dot. I couldn't get the subscript here. So that is the actual formula. Y minus y1 is equal to m times x minus x1. Now, we're also going to be introduced to a new aspect, a new way of looking at the question also, where sometimes you're asked to not only write it in the general form, but you're actually asked to write the equation of a line in the standard form. So very interesting concept here. We're going to be learning some stuff. So let's just jump right into the video and see exactly what this is all about here. All right, so first thing that we're going to be looking at is this question here. It says that given that a straight line passes through the points 2, 9, and minus 1, minus 3, we are required to determine the equation of the line in the form ax plus by plus c equal 0. That's what we're going to be looking at. All right. So we're going to be looking at this. So of course, naturally, you know, the first thing that we have to do here is to actually label our points. So this is going to be here. This is going to be here x1, y1 and x2 y2. That's the first thing we get about doing, guys, labeling our points. Now let's get into finding the gradient. In our previous tutorial we said this, the first thing that you have to establish is the slope of the line, the gradient of the line, if it is that it's not provided. So we go ahead and we say here that m is equal to y2 minus y1 over x2 minus x1, and this is just literally follow up from the last video. I really should have did this aspect in the last video, but of course we're not going to be doing a lot on this, right? I'm just introducing the new effective method here, but we did went through a whole entire bunch of questions of how to find the equations. So nothing that is being done here is unfamiliar unless you are watching this for the first time, so be sure to check those 2 other tutorial videos out. All right, so here we have the fact that y2 here is minus 3, and we're going to take away y1, which works out to be 9, over x2 here, which is minus 1, pardon me, take away x1, which is 2. So math this out, we end up with minus 12 divided by minus 3, and so negative divides into negative is a positive, and 12 divided by 3 is 4. All right, so we end up with a gradient here of 4. Pretty easy. All right, nicely done. Now once we have done that, then in our previous video we would have used the formula y equal mx plus c. Now we're going to be introducing the new concept of y minus y1 is equal to m times x minus x1. All right, and so therefore now we're going to be looking at doing some substitution. Now here obviously we're going to be using 2 and 9 as our x1 and y1 value, so let's have a look at that. So y, take away y1 here is 9, and m works out to be 4, open bracket, x minus x1 here works out to be 2. All right, so naturally if we kind of simplify this, we end up with y minus 9 is equal to algebraic skill, distribute, so that's 4 times x is 4x, and 4 times minus 2 is minus 8. So therefore transposing the minus 9 to the right side, we are going to end up with y is equal to 4x minus 8 plus 9, which naturally works out here to be y equal 4x plus 1. And that there is the equation of the line. Now that is in the general form. They did say that they want it in the form here, ax plus by plus c equals 0. Now in the event that you happen to be working a question and they've instructed you to write it in this form, that simply means that we're going to have to just try to get all the variables and terms on the left side. So currently the only thing that is on the left side here is y, so let's just transpose this 4x over here. We're going to end up with negative 4x. all right, the y is already on the left, so that's going to be positive y, and then we're going to transpose the 1 over here, so we're going to end up with minus 1, and now everything is equal to 0. All right, now in addition to a question like this, you might find that they structure the question exactly as you're seeing here on screen, and in addition to that, they'll say state the values of a, b, and c. What does that mean? What is a, b, and c? Well, obviously you can see here from the format that a is the number that is in front of x, so a would have been negative 4. B is the number that is in front of y. You don't see a number, but it's obviously 1. And c is the constant here, which is minus 1. So therefore a would have been equal to 4, b would have been equal to 1, and c would have been equal to minus 1 in the event that they ask you for a, b, and c. Now of course, lots of persons kind of prefer to work out the equation in the form y equal mx plus c. So I'm going to entertain you guys by also doing it this way. Now, not only am I going to be doing it this way, but I'm also going to show you that you don't have to use the 1 subscripts to get the answer. You can actually use the 2 subscripts and end up with the same result. So it really doesn't matter what you use as your x and y value. You just cannot cross-reference them. You cannot use an x value over here and use a y value over there. All right. So if it's either the 1 pairs or the 2 subscript pairs, it's just an option that you have. Okay. So here, naturally, y is going to be negative 3. And we had calculated to before. X worked out to be minus 1 in this case, plus c. So we end up with minus 3 is equal to minus 4 plus c basic algebra skills transposed to the left. Minus 3 plus 4 works out to be C. And naturally now you can see that C here works out to be 1. So we attain the same value that we had calculated here. Now in this case, using this method, we have to draw a conclusion to say therefore y is equal to 4x plus 1. And in addition to us getting the equation of the line in the general form, they had said to us that they wanted it in this form. So the same procedure here, transpose the 4x here, we end up with negative 4x. Leave the y on the left because it's still there, transpose the 1 here, end up with minus 1, and that's equal to 0. Alright, and that there is the equation of the line in that particular form. Alright, now leave me a like, guys, already if it is that you're getting some sort of value from what has been explained. This is just a simple continuation or a wrapping up of equation of a line. Everything here is familiar. If it is that it is unfamiliar, be sure to check out part 2 where you get a lot of clarity as it relates to what was done. Alright, so we're going to jump into the real essence of what this particular upload is about, and we're going to be talking about parallel lines. What exactly are parallel lines? We're going to take a look at that. Now, parallel lines are lines that are traveling in opposite or same direction without meeting. What does this mean for us in coordinate geometry? This simply means that if two lines are parallel, or it says that two lines are said to be parallel on the Cartesian grid, provided that they have equal slopes, or if we rather to say equal gradients. So it means then, hypothetically speaking, should I be working out a particular question from a particular paper and I calculate the gradient of a line, let's call it M1, and we worked it out to be 2. And then it so happens that I'm working another question now and I calculated another gradient, let's call it M2, and let's say that it happens to be also 2. All right, and it could also be another gradient, let's say M3, right? And I also worked it out and I get 2. What does this really mean for us when we're getting the same gradient? What does this mean? Alright, so what does this mean for us? We're getting 2 here, we're getting 2 here, and we're getting 2 here. Once you are calculating the gradient of a line or lines, then you're going to find that if the same gradient keeps appearing, then all these lines are going to be parallel to each other. And that's exactly what we're looking at, right? So that's the key principle here. Nothing new is going to be learned. No new formulas are going to be applied. It's just application and understanding of what is meant by parallel lines. So that means if I calculate the gradient of a line, then automatically I have also calculated the gradient of every and any line that is parallel to the original one. All right, so we're going to call this blue line here, I'm going to call this blue line here M1. So once I've calculated the gradient of the blue line here, which is M1, then automatically the gradient of the red line here is going to also be the same. All right, so with that said here, let's jump into a particular example where we're going to be looking at a question. All right, and here you're seeing a new concept of, we're going to talk about collinear lines later on when we're discussing vectors, but collinear lines are really, it's like two lines merged together as one. So we say that they're collinear, but we're going to get into that later on. All right, now I did say to you that I had introduced the new concept or the new application of y minus y1 is equal to m times x minus x1. But if it is that you guys feel comfortable in using y equal mx plus c, then by all means, you are not going to be instructed as to which formula to use. I just personally believe that the new effective method here, as discussed, gets us to our answer a lot easier. But again, it comes down to personal preference. Let's have a look at some examples here. So here we're looking at the question here that says, given that the line CX has coordinates C, which is minus 5, 2, and X, which is here 2, negative 1, our task is to determine the equation of the line in the form AX plus BY plus C equals 0. This is what we call the standard form of the equation of a line. And also that it's parallel to CX and it's passing through minus 3, 5. Now what I find that a lot of my students have a problem with, and I'm not sure if you are one of those type of students, you often have a problem in identifying what do I do first? You may have, bits and pieces of information, but sometimes what I do is that I tell my students that use clues in the question. Use clues to get things done. Now in the question, there's always going to be keywords that will kind of indicate to you what needs to be done here. All right. So what I see here in this question is the fact that, hey, equation is a keyword that kind of sends a message that I need to look at something specific. I also see a word here, parallel. All right, we already know what that means. We had just discussed that when two lines are parallel, then it simply means that the gradients are the same. We're also looking at this method here, ax plus by plus c. Once you get a question, right, that you have the answer written a certain way and you're being asked to rewrite the answer another way, it means that some sort of transposition will need to take place. So I cannot really address this aspect of the problem until when I'm all the way down to the bottom. And another thing here is that, hey, it's passing through a different point. What does that mean? They are two different lines. They are not collinear, so they won't have the same point. So if I'm going to be finding the equation of a line that is parallel to CX, then obviously they're going to have different X and Y intercepts on the grid. So clearly this is going to play an important role into the problem. Let's jump into it. Let's first address the whole concept of the line being parallel. We know that M1 is going to be equal to M2. So let's go ahead and find M1, because once we find M1, then naturally we would have found M2. And of course, you know the formula for M1, M2, doesn't matter. It's going to be Y minus Y1 is equal to M times X minus X1. All right, pardon me. M1 is equal to Y2 minus Y1 over X2 minus X1. Got my tongue twisted a while ago, guys. So, okay, here we go. M1 is equal to Y2, which we had indicated up here to be minus 1. Take away Y1 here, which is 2. And X2 here works out to be 2. Take away X1 here works out to be negative 5. So that's 2 take away negative 5. This works out here to be minus 3 over 7. All right, minus 3 over 7. So this is going to be the gradient of the original line, which is CX. Automatically now, that simply becomes the gradient of the line parallel, or any line that is parallel to CX. So the gradient there is going to be minus 3 over 7 for M2. Next, now we're looking at the whole idea that, hey, equation that implies that this is going to play an important role. So that's Y minus Y1 is equal to M times X minus X1. So Y minus Y1, all right, let's plug some numbers in. Y minus, and then obviously now we need to determine what is Y1. Because now we can't use the Y1 value that is up here. That belongs to the line CX. That's a point, or that's an ordinate value on the line CX. We have to use a point or an ordinate value that is on the line parallel to CX. So obviously down here is going to play an important role. This is going to be your new X and your new Y. So Y1 is going to be 5. M naturally is going to be minus 3 over 7. Times X1 here, or X minus X1 here, is going to be negative 3 here. Okay, and so we're going to simplify here. So Y take away 5 is equal to, let's distribute here. Naturally we already know how to distribute a fraction. Numerator distributes the term, divides by the denominator. So that's minus 3 times X. That's minus 3X over 7. And we have a clash of sign here. So these two signs clash, gives me a plus. But it so happens that negative 3 is now going to multiply positive 3, and we're going to end up with negative 9. All right? And that's going to be negative 9 over 7 there. All right? So that's how we get that aspect. All right? If you want to simplify this one first and then distribute, it's entirely up to you. But yeah, we're just going to take a couple of steps in one. So here we have Y minus 5 is equal to negative 3 over 7x. Pardon me. Let's remove this 5 here. We're going to transpose it. So it's going to be Y is equal to negative 3 over 7x. And we're going to transpose negative 5. And we're going to end up with a positive 5. And then arithmetically, the only thing that we can do here, guys, is naturally just work out this aspect. There's nothing here. We have already gotten our mx, we already have our y, so we just need to evaluate and calculate c. Now you can go ahead here and find the LCM, or you can use a method that I refer to as the butterfly technique. And so with the butterfly technique, let's just zoom up a little bit here for you. With the butterfly technique here, it's just a mental way of working out the problem really quickly. We just simply multiply here, that's minus 9. And we're going to multiply here, that's 35. That gives you the butterfly. And then simply now we just multiply the feet of the butterfly. That's going to be 7. 7 times 1. So that's kind of like a method that I use really to help us, or help me, get the problem out quick and fast. Alright, so negative 9 plus 35, that's going to be 26 over 7. Alright, and so that's going to be my y-intercept. So naturally here now, I end up with here, y equal negative 3 over 7x plus 26 over 7. Alright, and that is going to be the equation of my line. Now they did say to us, and if you look, we don't want to get too involved into the question and forget what they've asked for. They did say that we should determine the equation of the line, which we have, but they want it to be in the form ax plus by plus c equals 0. So naturally, shuffle up something here. Alright, I'm gonna write it down here, guys. We're gonna shuffle up this thing here and try to get the x, y, and constant on the same side. So I'm just gonna transpose the negative 3 over 7x over here. So I'm gonna get positive 3 over 7x. I already have the y here, so that's gonna be plus y. And I'm gonna transpose the 26 over 7 to the left also. I'm gonna get minus 26 over 7, and that's gonna be equal to 0. All right, now we can have it, we can have it stay here, but I think that we can do a little better by removing that 7. So if I go ahead here and I perhaps say multiply throughout by 7 to remove the 7 here, then you're gonna find that, hey, this 7 here will cancel this 7. There's nothing to cancel here. This 7 will cancel this 7. So we end up with a really nice answer here, where we see that the answer is going to be 3x plus 7y minus 26 equals 0. And we get a nice answer there. All right, and I really like this method. I think in previous tutorials I would have already told you here to multiply it throughout by 7 and then transpose. I think that once I transpose and then multiply by 7, my answer will pop out. All right, so hopefully you guys got a hang of that. All right, they might say to you here, state the values of a, b, and c. So in the event that they do even say that, then naturally you will see that a is 3, b is 7, and c is minus 26. All right, so hopefully that works out. Leave me a like down below, or just leave your comments if it is that aspect of the math is clear. All right, really good. Let's have a look at another example down here and kind of wrap up this. Remember that there is nothing new being learned as it relates to a formula. I'm just going to erase this, guys. Hope you guys have this. All right, so there's nothing new being learned as it relates to this particular formula, right? This particular topic, there's no new formulas. Everything is just an application process here. So once again, let's jump into it. Okay, all right, and a straight line passes through the points -2, -1, and -1, 7. We are required to determine the equation of the line parallel to it in the general form that's passing through 4 minus 3. Right, so we don't really need this ax plus by plus c, because the general form is in fact y equal mx plus c. So naturally we're going to jump and start off by labeling our points. We know that that's the norm, so that's x1 y1 x2 y2, and obviously now we are going to be looking at here finding the gradient because it was not provided. So m is equal to y2 minus y1 over x2 minus x1. Let's pump this in here. We're going to end up with, let's go down here. All right, so m works out to be y2 is 7, take away y1 is -1, over x2 here works out to be -1 minus x1 here is -2. All right. So now we end up here with negative times negative is positive, so that's 8. And negative times negative here is positive, so that's -1 plus 2. -1 plus 2 is 1. All right. So we end up with a really nice gradient here of 8. All right. 8 is our really nice gradient here. All right. So that's pretty good. All right. We get a nice number. Once we get a fraction, it makes the problem a little bit more difficult, but very doable. All right. But once you get a whole number, very smooth. In the general form here, we're looking for the equation of the line that is parallel to it. So we already calculated m1, so we know that m2 is also going to be 8. All right, and then we see here that it's passing through. So we have already identified our key points: passing through, parallel, equation. Equation would simply mean that we're going to be using the form y minus y1 is equal to m times x minus x1. If you so desire, by all means, guys, continue working with y equal mx plus c. I don't think a question is going to instruct you to use this particular formula. They may instruct you to put it in a certain form, but they won't tell you to use a particular formula. You use whatever formula is best. But it's good to know both in the event that they do come with something like that. All right, CXC is kind of unpredictable, so we can't limit our own potential. So here we have y minus, and we hear y1. Are we going to be using the y1 here? We're not. This y1 here belongs to the line, the original line. We're going to be using the y1 value that it's passing through. All right, this is the part that I want you guys to get. So y1 here is going to be -3. The new y1 value, that is. All right, we can call it y3 if we want to, but okay, y1 here. So that's y take away -3. And that's going to be equal to m, which we had calculated to be 8, times x minus x1, which works out here to be 4. All right. So negative times negative is a positive, so we end up with y plus 3. All right. You've got to be careful of your signs, guys. All right. Your signs are important. Okay. 8 times x is 8x, and 8 times -4 is -32. All right. And by transposing this to the side here, we end up with y is equal to 8x minus 32 minus 3. Nicely here we worked out the equation to be y equal 8x minus 35, and that is our equation in our what? General form. All right, in our general form. All right, and if it is that they wanted it in the standard form, ax plus by plus c, we know that we just naturally transpose the 8x over here, so we end up with -8x. Y is already over there, so that's positive y, and -35 here we end up with positive 35 equals 0. They didn't ask for it, but in the event that they did, then that's exactly what you would do. All right, so hopefully that is clear, guys, and you have some understanding of that. Check to see if you have the like button turned on, and of course share this content out to your math groups and so forth, guys, so that each one help one and we all can be successful and get rid of our fears as it relates to this topic. All right, now we're gonna go on to how we can actually implement the use of the graph paper now to actually work out a similar question involving parallel lines. All right, now I don't think it's necessary, but in the event that they do say to you that you have to use a graph, then we can. All right, so here's what we're looking at. So we're looking at the fact that the equation of a line, we're asked to determine the equation of a line that is parallel to another line with coordinates -2, -7, and 1, 1, and it's passing through the origin. Very interesting question here. We are to write the answer in our general form, y equal mx plus c. So this question is a little easy in terms of what we're expected to see here. All right, so let's look at some keywords in the question: equation here, parallel here, and passing through the origin. Those are the key terms in this particular question here. And naturally, you know, by now you should get it, guys, that the first thing we actually go about doing is ensuring that we know our x1, y1 values and our x2, y2 values. All right, make sure that you follow that exact routine. Do not stray away from the steps. All right, now we're not actually going to be using the gradient formula to find the gradient, since as we are going to go on graph, we're then going to go back to something that we had learned earlier regarding rise over run. So if you go back all the way where we had looked at part 1, we had looked at, hey, that the gradient of a line is actually going to be rise divided by run. So definitely take a look at that. That video is already out, so we can look at using the graphical method here to get to our solution. All right, so here we go. Before we can actually find the gradient, we need to plot the points on the graph. So -2 -7, that is obviously taking me in this direction, so that's going to be -2, that's -2, that's 1 2 -7, 1 2 3 4 5 6 7. So we are going to be somewhere here, right? I think that's okay. Let's just make it a little better. All right, that's fine, that's fine. So that's -2 -7 here, and then we're going to look at 1 1, so that's 1 1, so that's right here. All right, so that's 1 1 here. Okay, that's going to be here and here. Okay, so this is going to be my line. Oops, pardon me. Pardon me, guys. All right, there we go. Just had some. Okay. All right, so that's going to be my line. There we go. All right, as best as I can without any ruler. All right, and so now we're going to try to determine the gradient of the line. All right, and we already know that the gradient is going to be rise divided by run. Okay. All right, so the distance of my rise here. All right, let's count the unit of measurements here. So that's 1 2 3 4 5 6 7 8. So my rise here going down is -8. And now I'm here, I'm running. So I'm running to the left. That's also negative. So that's 1 2 3. So that's run is -3. So based on the formula here, we find that m is equal to rise over run. So m here is -8 divided by -3, and a negative divided by a negative gives us a positive result. So that's 8/3. So that's our gradient there. All right, so that is how you can actually use the graphical method to find the gradient. All right, definitely check out a full tutorial on that in part 1. Okay, now once we have done that, now we can get back to the meat of the matter, which is obviously going to be finding the equation of the line. And so of course we know that the equation of the line here is y minus y1 is equal to m times x minus x1. Please bear in mind that they did say that it is parallel, so we've got to make sure that we know that it's parallel. Okay, so we know that m1 that we just calculated 8/3 is going to be the same gradient that we're looking for down here. All right, and so y minus, we need to determine what is y1. Now normally they would say that it's passing through a particular point. Now this time they say that it's passing through the origin. So what is this? The origin is actually the center of the Cartesian plane here. All right, so the origin is right here as we see it. And so for those who don't know, that the origin coordinates is actually 0 0. All right, that's the origin coordinate value. Now usually, I mean, we could actually end the question now. We don't even have to plug the numbers into the formula, because once the line is passing through the origin, we say that the intercept is 0. So we would automatically know that c is 0. But just for the purpose of the video, then y1 here is going to be 0. M is going to be 8/3. X minus x1 is going to be 0. All right, so that's worked so nicely to be here is y minus 0 is equal to 8/3x. 8/3 times 0 is 0. So if we transpose here, we're going to end up with y is equal to 8/3x plus 0. Sorry, pardon me, that's minus 0. Right, and that's going to be 0 minus 0. So naturally now we work out here to be y equal 8/3x. We don't have to write the plus 0, but if you do, yeah, that's fine. Okay, so the equation of the line is going to be y equal 8 over 3x. Now, as I said, we didn't have to really go through this process. Once you're told that it's passing through the origin, then automatically we know that the intercept on the y-axis is going to be 0. So we don't have to go through all that. All right, so that is going to be the equation of the line. Did they say they want it in the form y equal mx plus c? Yes, they did. So we have our answer right here, y equal mx plus c. All right, so that is it really. 3 really nice examples when it comes to finding the equation of a parallel line. Hopefully you guys got some understanding on that and you are clear. All right, so let's get into the final aspect of this particular video now, and we're going to be looking at perpendicular lines. All right, and as I said to you before, guys, there's nothing really different about what we're doing here. All it is just understanding what does the terminologies mean, perpendicular and parallel. Now, we did establish that parallel lines means that the lines will have equal gradients. What does perpendicular line implies? Perpendicular line really implies that the gradients are the negative reciprocal of each other. What does this mean? Let's break it down. Now, hypothetically speaking, right, it says here that 2 lines are said to be perpendicular to each other if the product of their gradients is equal to -1. So what does product mean? Product means to multiply. And so what this is saying is that hypothetically speaking, if I were to work out the gradient of a line, and let's say that I ended up with 2/3, right? And I happen to work out the gradient of another line, and it so happens that the gradient becomes -3/2. Then what this means is that I could actually tell by calculation if the lines are going to be perpendicular. Before we get to that, what does the term perpendicular mean? It says here that the term perpendicular refers to the lines intersecting at 90 degrees. So clearly on graph here you can see a red line and the blue line, and this blue line here is actually intersecting with the red line at exactly 90 degrees. What does this mean for us? This simply means that if they intersect at 90 degrees, then the gradient of the blue line, let's say hypothetically speaking that the gradient of the red line is 2/3, and let us say that the gradient of the line, blue line, is -2/3. If I take 2/3 and I multiply it by -3/2, if I get -1 as my answer, then a conclusion that can be made is that the lines are perpendicular and they will meet at 90 degrees. So you can see here that the 2 cancels the 2, and 3 into itself 1 time, and 3 into -3 goes -1. So 1 multiplied by -1 is -1, divided by 1 times 1 is 1, and -1 divided by 1 is actually equal to -1. So that simply means that whatever lines these are, wherever they are on the Cartesian grid, because the gradients are like a negative inverse or negative reciprocal of each other, then we say that they are perpendicular. All right. So the formula basically, if it is that you want to calculate the perpendicular gradient using the original gradient, then naturally, once you multiply the gradient, original gradient, or once you divide -1 by the original gradient, you'll get the perpendicular gradient. Now, there's actually a legal method in terms of, let's say, for example here, how can we actually avoid the whole concept of m1 times m2 equal -1? That is really good to know though, all right? But you can actually look at the original gradient and be able to calculate the m2 without going through the process, all right? Not saying that you shouldn't, but there's actually a different way. So I'm going to draw up a table here. I'm going to call this side of the table here my original gradient, and I'm going to call this side over here my perpendicular gradient. Because in order for me to find the equation of the perpendicular line, I'm going to need the perpendicular gradient. So hypothetically speaking, let's start with a simple example. Let's say that I started with the gradient. Let's say I calculated the gradient of a line to be 2, right? How can I look at this and be able to determine what is the gradient of the perpendicular line? Now, naturally, 2 is over 1 as a fraction. So the rule is we simply invert 2 over 1, which will get 1 over 2, and then obviously we're going to change the sign, right? So 2 was positive, it's going to become negative. So therefore the gradient of my perpendicular line will be minus a half. Let's say hypothetically speaking we're working out and we got a gradient of minus 3. Then minus 3 is actually over 1. Inverting this will get 1/3. And obviously because minus 3 is negative, or because 3 is negative, then we end up with a positive. So that would be my perpendicular gradient here. And over here now, let's say that it's easy to work with a fraction. Let's say that we have 3/5 as our gradient. So if I invert this, I'll get 5/3. And because the 3/5 was positive, this is going to become negative. And if it's minus 2/3, then inverting this, I'll get 3/2. And 2/3 was negative, so it becomes positive. So we're good to go. So therefore, if you were to take the product of any of these here, you'll find that the result here works out to be minus 1. Alright? And so we can avoid going through this whole process of m1 times m2 simply by just using our interpretive skills. Invert and change sign. Alright? So that is how we can actually do that. So hopefully you guys got that aspect. Alright? Now, we're going to look at an example. There's actually 2 examples that I wanted to look at for this particular video. This is one that I had written prior when I was making the video. Handwriting is a bit atrocious, but hopefully you guys can be clear. I'm going to try to go through another one with you that talks about the perpendicular bisector. Actually, I have to. Alright, I cannot leave this video without going through that. So here we go. Little bit atrocious, but let's have a look at it here. It says that a straight line passes through the points -1, 4, and 3, -2. Our task is to determine the equation of the line passing through -1, -3, and it's perpendicular to it. Alright? So we're going to go through the whole process because, of course, their keywords here are equation, passing through, and perpendicular. Let's address the perpendicular aspect. The moment we see the word perpendicular, just as when we saw the word parallel, it kind of hinted to us that we need to go ahead and find the gradient. So m1 here is going to be y2 minus y1 over x2 minus x1. We already labeled our points, which we know it's the norm. So -2 works out to be -2. Sorry, y2 works out to be -2. Pardon me. And y1 here works out to be 4. Over x2 here works out to be 3. Take away x1 here works out to be -1. So this is -6 over negative times negative is positive. So that's 3 plus 1 is 4. So this reduces now to being 3/2. Alright, so that's 2 into 6, 3, 2 into 4, 2. So our gradient here of the original line is -3/2. Alright, so therefore that's m1. So from basically what we just discussed earlier is that once we know what m1 is, then we can actually find m2. Because m2 now is going to be the negative reciprocal. We're going to turn this upside down. And we're going to get 2/3. And check to see it was negative. So it's now positive. So this is the gradient that we are now interested in. We're no longer interested in m1. Right? Good. Now, we're going to still use the formula y minus y1 is equal to m times x minus x1. But if, again, guys, if you are comfortable with using y equal mx plus c, that's entirely up to you. Right? So here we go. Y, and we know that y1 is not going to be the y1 value that we have up here because we're not looking for the gradient of we're not looking for the equation of the original line. We're looking for the equal line that is perpendicular to the original. So it's passing through -1, -3. So we're going to insert -3 here. So that's y minus -3. And that's equal to m, which we had calculated. m1 was -3/2, so we're interested in m2, which is 2/3, times x here minus x1, which we know is -1. Alright, so little bit of sign clashes here. Let's simplify this a bit. So y, negative times negative is positive, 3. And that's going to be 2/3 times x. Negative times negative is positive, so that's plus 1. Simplify it, makes it a little easier to work out. Let's do some distribution. They didn't ask us for any particular form, not standard form, not general form, so I'm just going to stick with the general form. So that's y plus 3 is equal to 2/3 times x is 2/3 x, and 2 times 1 is going to be 2, again over 3. Alright, and so naturally now we're just going to transpose this 3 over here, so we end up with y is equal to 2/3 x plus 2/3, and we're going to transpose this over here, we're going to end up with minus 3. Alright, and we're going to simplify this little fraction here. We're going to be using the butterfly wings. So here, alright, I'm going to be using the butterfly wings. So here, that's going to be 2 times 1, that's 2. And 3 times minus 3, that's minus 9. Over 3 times 1 is going to be 3. Alright, so we end up with minus 7 over 3. Okay. So we're good to go here. Alright, so we have our C. Alright, so we end up with y is equal to 2/3 x minus 7 over 3. Alright, and that's going to be the equation of the line in the general form. Alright, in the general form. And in the event that we needed this to be in the standard form, you guys can get it in the comment section here below. Let me know if you got minus 2x plus 3y minus plus 7 equals 0. Do it, transpose it, and let me know in the comments if you got it right, if you got that same answer. Okay, so that's basically what the whole concept of coordinate geometry entails. There's actually one more question that I'm going to have to write here on screen for you. Let me know if it is that you are understanding. All right, and feel free to watch the video over so you can get a clear understanding, and you should be okay. All right, we're gonna wrap up this video here. Let's do one more question. Determine the equation, pardon me, determine the equation of the perpendicular line determine the equation of the line perpendicular to the points -2, 7 and 3, -5, which passes through M. All right, which passes through M. Right, very vague question though, very vague. It's not much to go on, but of course math is all about interpretation and understanding and application. So as usual, the keywords in the question here is equation, perpendicular, and passes through. Those are the keywords. I do apologize for the atrocious handwriting, but I'm sure you can understand here as we are writing. All right, so naturally here it says that perpendicular. So with the word perpendicular, that implies that we need to find the gradient. All right, so that's m1 is equal to y2 minus y1 over x2 minus x1. So y2 here works out to be, let's label our points as usual, x1 y1 x2 y2. So y2 here works out to be -5 minus y1 here works to be 7 over x2 here works out to be 3. Take away x1 here is -2. So we end up with here is -12 over 5. Negative times negative is positive. 3 plus 2 is 5. So our gradient here is negative 12 fifths. Okay? Now, it says that here we're looking for the equation. So that means, well, before we get to the equation, we already found the gradient of the original line. So we need to calculate M2. And as said before, all we have to do is take the gradient, reciprocate it, and change the sign from negative in this case to positive. So this is the gradient that we are interested in. We're no longer interested in the gradient of, or the gradient M1. Alright, so we got the perpendicular aspect out of the way. Now we're going to looking at the equation. So that works out here to be y minus y1 is equal to m times x minus x1. So what is our y1 and x1? Well, usually you're told what point it's passing through, and here it passes through m. So what is m? You would have already been exposed to something that we had discussed earlier when it comes to finding the midpoint. And so if you go all the way back to a concept that we learned here, and here it is on screen, midpoint formula is m. So m is that formula. So this particular question, although so very vague, it requires us here to do a lot of work, right? And so this means that we're going to have to find m before we can actually work out this part here. So this big M here is actually equal to x1 plus x2 over 2 comma y1 plus y2 over 2. All right, so that's when they're telling you that it's passing through the midpoint. All right, so let's work out m. So x1 here, let's go back. X1 is minus 2 plus x1 is minus 2 and x2 is 3 over 2 comma y1 is 7 plus y2 is 5, or it's negative 5, over 2. So m here works out nicely to be 1 over 2 comma 7 plus minus 5 is 2 over 2. And so m here, which is the midpoint, works out to be a half, comma 1. So that's m. Now, sometimes they'll say that it's passing through m, and there are other times where they'll say that it's the perpendicular bisector. That's what they'll say. They'll say that it's the perpendicular bisector. Now, I didn't actually have a question on this particular tutorial that uses the actual word perpendicular bisector, but in the event that you happen to see a question that relates to perpendicular bisector, then the perpendicular bisector is indicating to you that the line is passing through the midpoint. It's passing through the midpoint. So just look out for that. All right, so now this is going to be our new x1 and y1. All right, because that's the line. It's passing through m, and m is a half 1. So just look out for that. All right, so now we're ready now to get over here. So y minus y1 in this case is 1. M, the one that we're interested in, is the one in the red box. This is 5 over 2, 5 over 12, pardon me. X minus x1 is a half. All right, so here we go. We end up with y minus 1 is equal to 5 times x is 5x over 12. And naturally now we just say 5 times minus 1 is minus 5. And 12 times 2 is 24. Okay, so top, bottom. Okay, 5 times x over 12, 5 times minus 1 minus 5 over 12 times 2 is 24. Okay, transpose the 1 here, we end up with y is equal to 5x over 12 minus 5 over 24 plus 1, transposition. And of course we can simply work this out. Y is equal to 5x over 12. When we work this out, you're going to find here that the answer is actually 19 over 24. Okay, and that there is the equation of the line written in the general form. All right, when you work this out, let me know if you got 19 over 24. Put the 1 over 1 and find the LCM, or you do the butterfly method. You should get 19 over 24. All right, if you wanted this in the general form, then we simply going to multiply both sides by 24. Right, so if you wanted this in the standard form, pardon me, then we could see 24y. Right, when you multiply this by 24, you're going to find that this is going to be equal to 10x. And when you multiply this by 24, you end up with 19. So naturally now, our equation is going to be minus 10x plus 24y minus 19 equals 0. That's going to be the equation of the perpendicular line in the standard form. All right. So yeah, that is pretty much it. This is a wrap as it relates to coordinate geometry, part 3. This covers every little details as it relates to perpendicular lines, parallel lines, and just in general applying a more new effective method when it comes to equation y equal mx plus c. We are going to be using the formula y minus y1 is equal to m times x minus x1. All right, so this brings us to the end of this particular tutorial. Please be sure to share all 3 to your math groups, friends, or anybody who you know are struggling with math in this area. And just let me know if it is that it's very helpful in the comment section down below. Check the description box, you'll find links to get direct access to me, where we can do personal one-on-one tutorial on the internet. Do take care until next time. My name is Akeen, and keep on practicing. Take care. Bye-bye.